Thank you for the intro. Yeah, thanks everybody for joining. And yeah, the first topic that I'm presenting today is the search relevance, how to label it. I think it's fair to start with presenting the company that I'm working for, and that's Alex Europe, that operates in a few countries, mostly in Eastern Europe. And this is the scale of the operations you can see here. We are hosting over 40 million listings, ads, items that people are trying to sell, and we have over 100 million monthly active users. We are based in Berlin. We have some other offices in Portugal and Poland, and somewhere else. And I'm a data scientist. Here in Berlin, just to give you a bit of a context. But closer to the topic of the presentation, this is the main functionality of the platform, that is search. So when you go to OLX and you want to buy something, you typically go to the search section and you type in your query. So in this example, you can see the iPhone X is the search query. And the task of the search engine is to find the most relevant ads to return to you. And the problem with the search relevance is that there are a lot of ads. As you can see, there are millions of listings on the platform, and among those, there are a lot of iPhone X listings. Right? There are many people willing to sell their phone. There are some businesses that are selling phones as well. So there's a lot of competition. But apart from that, these listings are user generated. So people generate the titles and the description of the ads. So it's not always trivial to match the query with the listings, and that's what we will try to uncover a bit more going on. So this is the plan. First, we will define the search relevance problem in our case of the online classifieds, and then we will talk about the labeling project that we've been using to solve this problem, and then I will share some insights and tips and tricks that we are using, and then we will talk about like the results and the learnings of this project. So to start off, we have to define what relevance is, right? Like it's kind of intuitive. You want to get some relevant results, but what it exactly is, like how you approach this problem. So if you go to a dictionary, you might find these. One of the definition will be that the relevance is the ability to retrieve material that satisfies the needs of the user. And the key term here is the needs. Right? So how you understand the needs of the users. That is mainly the search query that we saw before. But it's not self-explainable, right? The search query doesn't tell you which exact product you're willing to see as a buyer. So to narrow down this scope of the listings that we want to show to the users, we define relevance in a stricter manner and more specific. So in our case of the online classifieds, we make a very bold assumption, and that is that user wants to buy a specific product of specified characteristics in a functional state, unless explicitly stated otherwise. What that means is, like in the example on the right, if you go and you tell the search engine that you're looking for PS5, then the most relevant ads for you will be the PlayStation 5 console. It won't be a dysfunctional PlayStation 5 that you might use for replacement of some parts. It won't be a game for PS5. It won't be PS4 or any accessory to it. These listings will be relevant only if you specify that you are looking for an accessory or a game and so on. This framing helps us to, first of all, label the data easily, and second of all, in the end, train a model more easily. But now, when we make this formulation, the problem is again how we find the relevant listings. So we've defined the relevancy. Now we want to collect the data to train a model. But before going to that, I have to mention like a couple of heuristics that you might use, and that is the text similarity. Some text similarity heuristics. You might just match the incoming query with the text that you have using some formulas that you just make up, or some industry standards like BM25 and so on. You might also try to just classify the category, and it will solve part of the problem when some items just fall out of the category that the users are interested in. So for instance, consoles versus games for consoles. But then these are only partial solutions, and they're very limited. So that's why we are going for a machine learning solution, and it starts with data. But then there are two major paths to collect the data. First will be the user behavioral data, or the logs that your application creates. The problem with that is these signals are very noisy, first of all, but more than that, they're biased, and they're biased in many ways. But the main issue we have with the logs is that they represent much more popularity of the listings rather than their relevancy. For example, some listings might get 0 or close to 0 interactions from the users. It doesn't mean they're relevant. Maybe they just have a too high of a price or an unpopular color in case of clothes or something. It doesn't mean that they do not satisfy query of the users. So this is why for these specific problems, I'm sorry, I have to mention that the logs are still useful in other problems. So the popularity that I mentioned, it is still a huge factor, and we train models on these data, but they're not solving the problem of relevance that we've defined. That is not less important, but it's not picked up by these models. That's why we're going for the manual labels. And the main concern with this approach is that it might be expensive and maybe hard to set up in the beginning. But we will talk about it. I think in the end, what the cost and the value of this is. So I'll describe our use case with Teloka that we've been collaborating with since last year. And you can, if you're not familiar with Teloka, you can see the typical like pipeline of work with Teloka. I'm sorry, the font is not straight here because of the last changes, I guess, in the slides. But yeah, Teloka as a crowdsourcing platform allows you to basically do something with the data that you have, right? To solve some problems. And the main thing that you have to define is a task. So that's what we first will talk about. So the main components to a task that you want performance to solve are guidelines, interface, and data. They are not independent, right? I have to say, but let's look into them separately, and we will start with the guidelines. So that's basically the instruction for the performance, what to do with the task that you're giving them, right? Because often it's not intuitive when they see the interface of the task. That's why you have to formulate what exactly you expect from people. And yeah, it's also important to mention some corner cases that people may face, and give some examples. In our case, there are quite a few corner cases that we have to define. Like, as I mentioned before, there are, like, for instance, what if the item is not functional, right? And it's not mentioned in the title, as we've defined, this item is irrelevant, right? And it may not be intuitive to the user if we haven't told them that, and they may go for the relevant label. So that's something that we have to clearly state and ideally give the examples. So yeah, as you can imagine, this document is quite extensive, and it will be available to them during these task solvement. This is how the interface looks like, that we've defined ourselves. We didn't actually use the interface builder, but just use JavaScript to make it up. And the goal was to make it as concise as possible. So you will see that there is only the most necessary information for the users to make a decision on. And it starts with a query. So in these tasks, we have a query corn in the category home and garden. Then we have multiple listings on beneath the query, and each listing is represented by a title, category, an image on the right, and then a description that can be also expanded. If the description is too long, it will be hidden behind this button. We will also display some parameters that can be defined in the listing to help to make a decision. For instance, like the condition parameter. And then what users have to do is to choose whether the ads are relevant or not to the query. Another important things for the interface that we went for is the hotkeys. Here you can see these 1, 2. That is the buttons that you can use to go through the interface. So instead of clicking with your mouse, you just click the buttons on a keyboard or on your phone. And also to submit the task, you can use another button, like a space, if I'm not mistaken. So that's again to make the usability as good as possible. We're in time still, all right. So yeah, here we are collecting these responses. So in one task, again, as I said, we have one query and multiple items, and it is another aspect of the usability. We don't want people to switch contexts all the time to analyze different queries. So for a single query, we will give them more ads at the same time. And you can compare these interface with screenshots, for instance, that one might use. So you could say, let's just make a screenshot of the search page. The problem with that, there are a lot of interface elements that are distracting performance, right? Also, a lot of information that is not useful, like the date, location, and so on. Also, you won't see the description here, so you have to go to the ad page. But then when you're on the ad page, there is even more useless information for this problem. That's what we came up with. This is our interface. And again, it's directly related to the guidelines, right? So these guidelines are telling you what to do with the interface. The last part is the data. So how we generate this data. The first thing is the sampling. So how we decide what data to show. And the first step is in sampling is the sampling of the queries. And there we're trying to represent multiple queries and categories as fairly as possible. Also, if for at a certain iteration we are more interested in a specific category, right? We will upsample that. Then, as soon as we have the queries, we are going for the listings or ads, and there again there are a lot of strategies. What we are doing, we are using our current search engine to match the ads, but we are not ranking them. So we are taking a random sample of those matched ads. It is also beneficial to take in some irrelevant ads, like completely irrelevant that are not matched by the current solution. Is some of them, first of all, might be actually relevant. Maybe there was a typo that was not picked up by a search engine. But also as negative examples, it might be useful. This is the main step, the sampling. And then what we also have to do is to link these examples with the content, in our case, the images. We have to store them in the cloud. So we are saving them to the cloud and putting and saving the links in the dataset that will be used later on Teloka. Yeah, and the last step here is grooming of the dataset and making the format of the dataset consistent with the interface, with the JavaScript. All right, now here the task is created. We have defined everything we need. Now we have to join these tasks into pools, and the main pool is what we want to be tagged, right? That's called the main pool on Teloka. But apart from that, there are different pools, and what we are using in OLX is so-called example. It is a data set that is labeled by us and is used as a first control step, like a gate for the users. And here, the pool starts with some filters on the Teloka's profiles, right? We have to define the languages of the market that we're interested in. So in this case, it was this project was done for Ukraine. So we had to specify the relevant languages, and we also defined the region by the phone number here and so on. There are many more parameters, but we are using only the basic ones to make sure that people can actually perform, that they can solve these tasks. But then to ban these scammers, we are using this example with the control tasks to ensure that people actually look into the guidelines and they're following the guidelines, right? And we have these skill that we created in the project. It's called control task performance, and it's basically just the percentage of the correct answers, correct responses. See, there are only 10 control tasks. Each task consists of around 5 examples, 5 pairs of query and item. So it's a good enough of an entry. Then if people pass the exam, they go to the main pool. And here, this is the place where we define the threshold. You can see that it's not very high. It is due to the formula that we use for this skill. You remember it's the percentage of the correct answers, but our task is actually 5 examples. So we have to reply to respond to all the 5 examples correctly to get a positive score. So it's kind of it's a very conservative metric. This is why it's very low here. But again, it can be different. Here you can see we have around 400 tasks that resulted in 400 task pages. And it's not just one-to-one mapping. It was just a coincidence that the number of pages were equal to the number of tasks is due to the 2 variables here. The first one is the overlap, so how many people we want to work on the same task, and the configuration of a task page. So in each page we have 5 tasks, and each task we want to be done by 5 people. That's why the number of pages is equal to the number of tasks, but again, it can be different. Right, these are just some details. You also have to specify the price and so on. Right, more to the results. A few numbers on the outcomes of this project. We use around 2,000 examples. As I said, like there are around 5 examples per task. That's how the number of tasks was inferred. And then it took us only around $20 to get this project done, including the fees and everything, and the scammers that went through. On the time scale, it took only 1 day, which is fairly short considering not the biggest audience, I guess, of the assessors in this market. And later on, we also validated the quality of the labels, and we estimated it at around like 10% error rate, including errors actually that were caused by misguiding the user. So the guidelines were not clear enough, as we learned after the project was run. And also some examples were just not trivial, like not clear, even with the perfect guidelines. Sometimes, yeah, like you have to make more assumptions. So that is again a conservative estimate. It definitely can be lower, but the main point is it's still a very good score. It can give you a good performance of the model, and more than that, it's much better score than of the behavioral data of the logs that you could collect from the app, if you try to treat that as the relevance. And a bit more numbers here is on the scale of the project. It was around like 200 people. Around 50 of them only passed the exam, and only 4 of them made it to the end. So kept their performance at the threshold, above the threshold, and worked on all the available tasks. So that's just to give you a bit of a hint on how it may look like. I guess the last bit of statistics I would like to share is the insight into the data that we've got from this project. Here you can see the distribution of the labels. So on the right is the positive labels, like the relevant results. On the left is the relevant search results. And you see most of the time people agree So these are the rightmost and leftmost bars. In the middle are the examples where performers disagreed. Again, it will include some scammers probably, but as I said, also some examples are objectively not clear. And most importantly, this bar on the left tells us that we are often matching queries with the relevant results, and that's what we are aiming at, bringing these results to the bottom of the search results or excluding them altogether. And that's what we will use this data for, like to train models to score the examples on the right higher, to bring them to the top. I hope I haven't missed anything. So I will try to sum up what I've shared today. We've talked about the search relevance and how we define the trial legs and to empower our search algorithms. And we've talked about the crowdsourcing solution that we are using, empowered by Teloka, and some hints and tricks that we've learned for ourselves to use for this specific problem of the search relevance. And in the end, I shared with you some statistics on the cost of this kind of project and the value that you can get out of it. Yeah, unfortunately, I cannot share any model performance at the moment. We are still developing these models, but as soon I think we will incorporate that into our search engine. So I hope we will share that soon. Yeah, this is the last slide, just to be a reference. I think I've overrun on time again.